This is Tim O'Brien from Seattle on November 6th, 2025. And now for today's news. First story comes to us from Anthony Spadafora of TechRadar. There's a VMware zero-day vulnerability that's actively exploited by Chinese state hackers. CISA just dropped an urgent warning about a VMware vulnerability that's actively being exploited. It's CVE 2025-41244. This affects VMware ARIA operations and VMware tools. And here's the scary part. It's already being used in the wild to compromise U.S. government systems. Now, this vulnerability, which scores a hefty 7.8 out of 10 on the severity scale, it allows attackers with limited local access to escalate their privileges all the way to root. In practical terms, if a hacker gets basic user access to a virtual machine, maybe through phishing or a compromised account, they can use this flaw to take complete control of the entire VM environment. This bug specifically affects systems with SDMP, that's Service Discovery Management Protocol, enabled, which is unfortunately common in most enterprise deployments. And what also makes this particularly urgent is that CISA has added it to their known exploited vulnerabilities catalog. This is a list of actively weaponized bugs. Federal agencies have until November 20th to patch or stop using the affected tools entirely. VMware released patches back in October, but clearly not everyone applied them fast enough. This is the textbook example of why patch management matters. The bad guys found this vulnerability and started exploiting it before most organizations even knew it existed. If you're running VMware in your infrastructure, this is your wake-up call to patch it today. For more information and links, please see the show notes. For today's programming language story, it's an interesting draft chapter written by Parth Parikh. He's currently working at Microsoft, and he appears to be also writing a book. He's published one of the chapters. And it's a chapter that focuses on managing millions of timers. So if you've ever wondered how your operating system manages millions of timers without melting your CPU, Parth Parikh has written this brilliant deep dive into timing wheels. It's an algorithm that makes it possible for systems like Kafka and Linux to handle timer operations at massive scale. So if you have to do millions of things in order, a naive implementation would just create a sorted list and step through them, checking to see when to run them. But this would create an enormous amount of load. Systems like Linux would spend most of their time figuring out what to do next. But what Parth describes in this chapter is that you place your timers into a hierarchy of buckets. Now, I won't go into the full details, but what's interesting here is that something that seems so straightforward is actually fairly complicated and brilliant. And it's a pattern that we've used across many different systems. It's an interesting book. I hope to read it when it comes out. And if you want to learn more about timing wheels and also the history of clocks, he talks about how Magellan ships carried Venetian sand clocks. And he also talks about the discovery of quartz crystals and how they're currently used as a timing source in the computer that you're using right now. If you want to read the draft of his chapter, it's available in his GitHub repository. There's a link in the show notes. Today's Weird Bucket story comes to us from Mark Tyson at Tom's Hardware. And this one is a dystopian tale about how we're too connected to the cloud. An engineer blocked his smart vacuum from phoning home to collect data, so the manufacturer remotely killed it. Now, the vacuum just stopped, but this developer didn't just accept defeat. They modded it with custom hardware and Python scripts to run completely offline. This is peak 2025 weirdness. The vacuum in question is a high-end model that requires cloud connectivity for basic functions like scheduling and mapping. When the owner, a privacy-conscious engineer, blocked its internet access to prevent data collection, the manufacturer detected this and issued a remote kill command. The vacuum became a $500 paperweight. No cleaning, no charging, just dead. And here's where it gets intense. The owner didn't give up. They reverse-engineered the vacuum's control board, wrote custom Python scripts to replicate the cloud functions locally, and even 3D printed new parts to bypass the manufacturer's hardware locks. It took weeks of work, but now they have a fully functional vacuum that never needs to phone home. Now, the manufacturer threatened legal action for, quote, circumventing technological protection measures, end quote. But they backed down after the story went viral. This is just such a weird situation, but it's a perfect encapsulation of our bizarre relationship with smart devices. We buy them. We don't even know when they're phoning home. But in this case, the manufacturer was trying to assert that we weren't allowed to do anything about that. It's also really bad timing. If you recall, 3 weeks ago, AWS had a cloud outage, and owners of expensive cloud-enabled beds realized that their beds were being locked at specific temperature settings, and they also needed to phone home. I think it's time for all of us to take a look around our space and figure out what is phoning home and why, and does it really need to? If you want to learn more about what this developer did to get their vacuum back online, you can see links in the show notes. In today's other news, Mozilla is ending support for its Japanese community forums after 20 years. They're citing declining participation and resource constraints. According to Mozilla support, this decision affects thousands of Japanese Firefox users who relied on community for localized technical help. It marks another step in Mozilla's ongoing restructuring efforts, and they've seen multiple community programs shut down this year. Apple and Goldman Sachs are reportedly ending their credit card partnership after mounting losses and regulatory scrutiny. The Wall Street Journal reports that Goldman is in talks with American Express to take over the Apple Card portfolio, which has struggled with high default rates and costly consumer perks since launching in 2019. This marks Goldman's retreat from consumer banking. Microsoft announced it's investing $4.5 billion in United Kingdom data centers over the next 3 years to expand its AI and cloud infrastructure. According to Reuters, this represents Microsoft's largest United Kingdom investment to date and will create over 20,000 jobs as the company races to build capacity for AI workloads across Europe. And the FTC has fined Amazon $30 million for violating children's privacy with its Alexa devices and Ring doorbells. According to the Washington Post, Amazon kept children's voice recordings indefinitely and used them to improve its algorithms without parental consent, while Ring employees were caught spying on customers through their security cameras. And that's the technology news for November 6, 2025. If you're interested in any of these stories, please see the show notes for the links. In today's episode, we're focusing entirely on a brewing cyber threat, modern attacks and worms that are targeting developer environments. I'm hoping that this episode serves as a wake-up call to developers who might not fully realize just how interested these things are in the credentials that they're storing in their file systems. We're going to break this into 3 segments. First, we'll explore why attackers are zeroing in on developer machines. Next, we'll dive into the 2 recent worms that have been shaking the developer community, Shai-Hulud and Phantom Raven. And then finally, in this episode, we'll outline concrete steps that developers must take to protect their credentials and environments. I need to reiterate before we dive into this material, if you're a programmer, if you write code, you're under attack. You might not even realize it yet. And we're going to talk about why you're such a great target. In this first segment, we're going to talk about why attacks usually target developer environments. It turns out that a developer's workstation, a laptop, it's a treasure chest of credentials. And think about it. When you develop software, you're connecting to a database. Hopefully, you're connecting to a development database and not production. But that's not always the case. Sometimes you're working with APIs that have keys. You might be checking code into Git. You might have a GitHub token. And a lot of these live in files. So if you think about what lives on a typical dev machine, it's API keys, database passwords, cloud tokens, SSH keys, NPM RC files when you're publishing packages. Essentially, the keys to the kingdom. And you're also the easiest target. If you're after something, you're not going to spend all the time and effort to assault a fortified production system. They're going to target the relatively soft underbelly, and that's your laptop. And the payoff is huge. Compromise a developer, and you're going to gain near root level access to just about anything. And that's not always true. If you work somewhere that has good discipline about credentials, where they're stored, who has access to them, it makes it tougher. But as a general rule, most companies let developers do whatever they want on their workstations. And this means there are files named keys that have keys. But why are these developers such easy targets? Frankly, many developers don't prioritize security in their day-to-day work. A recent Source Code Warrior survey found that a whopping 86% of developers don't view application security as a top priority when they're writing code. Only about 29% believe writing vulnerability-free code should be a priority. And over half admitted that they can't ensure their code is free of common security bugs. I'll also add another one. Every time I'm reporting about a CVE or a new vulnerability, and I talk to a developer, there's a really high chance that they have no idea what I'm talking about. Try mentioning Shai-Hulud to someone you know who programs JavaScript or Node.js. There's a really good chance they've never heard of it. Try mentioning Phantom Raven. No one knows what that is either. Developers just do not think about security. And in practice, what this all means is that secure coding practices take a backseat to feature delivery and deadlines. And it's not that developers are incapable, it's just that security has always been seen as someone else's job, or an afterthought. Let's write the feature first, then let's think about security. About 70% in these surveys rely on on-the-job learning for security, taking an average of 5 years of experience just to achieve minimal security knowledge. And in my own experience, it's not something they're going to teach you in college. You don't get taught about secure programming practices when you're getting a computer science degree or an electrical engineering degree. This is something that happens later. And in reality, for most developers, never. A lot of developers don't know the best practices or risks lurking in their workflows. The result, there's so much low-hanging fruit for these attackers. Let's consider the problem of secrets sprawl. These are credentials strewn throughout code and config. In 2023, GitGuardian scanned over 1.1 billion GitHub commits and found that 8 million of them contained at least one secret. And that's an enormous number of API keys, tokens, and passwords leaked into the public repositories alone. And I want to claim guilt here. I have an open source project and I inadvertently checked in my OpenAI API key because it was so easy. Now, I didn't have the right feature turned on in GitHub that would have made this impossible because frankly, it was an open source project and I didn't want to pay. But that's just an example of this is everybody. This is not just people who aren't paying attention. It's too easy to put your passwords, your tokens, your keys onto the file system. And it's very easy for developers to ignore security. So developers also often run tools, dozens of them, package managers, local servers, and these can fall behind on updates. Just look at the story that broke yesterday about React Native. A tool called Metro has a URL where you can just hit it from anywhere in the network and run a command local on a development machine. And that one, by the way, scored 9.8 out of 10 in terms of severity. A classic cautionary tale here is the LastPass breach of 2022. An attacker didn't crack LastPass via some 0-day on a server. They got in by exploiting a 3-year-old unpatched Plex media server on a DevOps engineer's home computer. That hacker installed a keylogger on that developer's PC, captured his master password, and walked right into the company's vaults. And that was all because one engineer didn't update his software on his home computer. It's a sobering example of how a single unpatched app on a developer's machine opened the door to a massive breach. And what's worse is that this was 3 years ago. This was before generative AI was here to help the attackers find new ways into your machine. And I also want to emphasize, most people who have their credentials stolen might not even know it. And we'll talk about that in the second part of this episode. And if you do have your credentials hacked, the other thing to know is, depending on who's watching or who's attacking, they could do some fairly nefarious things. One of the things they could do is actually build vulnerabilities into your code. Now, that's not the most common thing that you're going to see happen. You're going to see Shai-Hulud and Phantom Raven. Those are usually there to try to get as many credentials as possible. But if you are facing a well-funded adversary who wants to find a way in, not just to your code, but to your business. And it's like robbing a bank by stealing the manager's keys instead of having to blast open the vault. Let's be clear. You're a developer who works for a company, and that company puts an immense amount of trust in you. You likely have access to production databases, production systems. Verizon's data breach report noted that nearly half of the breaches involve the use of stolen credentials, often from a developer's laptop. In 2023, for the first time, compromised credentials eclipsed even exploits as the top cause of attacks, accounting for about 50% of attack root causes. Attackers want your tokens and passwords. Developers just happen to hold a lot of them, and often without even paying attention. I mean, think about it. Just think about right now on your file system, next to that Tomcat app or that Node app or that Rust application that you're building, there's probably a file somewhere that's named .env or keys. So if someone gained access to your laptop, that's the first place they would look, and they'd copy the contents. But I have to tell you, no one's logging into your laptop. You're doing it yourself. You're executing the script that's doing all of this to your laptop. And I'm going to talk about that in the second part of this episode. There's lots of credentials. There's lots of unpatched tools. There's low security awareness. But I think it's deeper than low security awareness. I think most developers don't even understand the risks that they're facing. And that's what we're going to talk about in segment 2. Segment 2 is Inside Shai-Hulud and Phantom Raven, a developer's nightmare. Now, if you've been reading the news, or technical news to be exact, you might have heard about Shai-Hulud, and you probably haven't heard of Phantom Raven yet. But these are not science fiction creatures. I mentioned this to someone the other day, like, have you heard about Shai-Hulud? And they laughed and they said, what, you mean from Dune? And yes, it's a funny play on a name of a worm in Dune. But it's also a real malware campaign that has affected hundreds of thousands, probably millions of people, and many of them don't even know. We're going to explore what each of these things did and how they work, and try to dramatize this scenario so that you understand how they work, and maybe check to see if you were compromised. First, let's talk about Shai-Hulud. This was named after the giant sandworms in Dune, and quite aptly so. Discovered around mid-September 2025, Shai-Hulud was the first known self-replicating worm in the NPM ecosystem. NPM, as discussed in previous episodes, is what's used to download JavaScript and Node.js dependencies. This was a supply chain attack. And what it was doing is was attacking the dependencies that you consume as a developer. When you write code, you don't write all of it yourself. You're leveraging libraries, open source libraries that are available from NPM's repository. And so that's your supply chain. That's where you're downloading your dependencies from. So what this did is it compromised a package. Shai-Hulud would run code on your machine after you installed it. Every time you install a package with NPM, it can run what's called a post-install script. And that post-install script on an affected package would scan your system for secrets and then use your own credentials to infect more packages. And this was a vicious cycle. Shai-Hulud transformed compromised maintainers and CI systems into a self-distributing network. And it all started when attackers phished an NPM package maintainer, or they otherwise got hold of their credentials to publish to npm.js. With that valid maintainer token in hand, the attackers could publish malicious updates to that maintainer's package. Those malicious versions contained the Shai-Hulud payload, and that was a worm that would execute automatically whenever anyone consumed that package. So we're talking about thousands, millions of affected people. And they would install a dependency that would execute a post-install script that would own their laptop. So here's the truly insidious part. To get compromised, developers didn't need to do anything risky. They just ran npm install, something they're doing dozens of times a week. Shai-Hulud exploited npm's post-install scripts, and those execute automatically. Most developers never think twice about these scripts running in the background. And when you consider that a typical React-based project can have hundreds or even thousands of dependencies, transitive dependencies, a simple Hello World React app created with a Create React app pulls in about 2,839 packages. That's ridiculous. So you might not even know that you were depending on an affected package, because there's something called a transitive dependency. You might be writing a program that only directly depends on 10 things, but those 10 dependencies have dependencies on a whole tree of other dependencies. So with full tooling like Webpack and Babel, sometimes that Create React app can download over 13,000 dependencies, and that's a crazy number. The compromised package could easily be one of these several hundred or several thousand transitive dependencies, and you might have been affected without even knowing it. So once running on a developer's machine or a CI runner, continuous integration, Shai-Hulud went through a multi-stage routine. First, it quietly checked the environment to see where it landed. Is this a CI machine? Is this Linux? Is this a personal laptop? If it found itself in a useful environment, say a build server or a developer workstation with access, it proceeded to harvest every single credential it could find. It combed through files like .npmrc, environment variables, .env, .env.local, and even cloud metadata endpoints for AWS and GCP credentials. When you use something like GCP, sometimes you can put a little JSON file on your file system, and that is your authentication. Tokens for NPM, GitHub personal access tokens, secrets used during deployments. Nothing was spared. And importantly, Shai-Hulud was fairly intelligent. It would validate the tokens on the spot. On your own machine, it would do what it needed to do to figure out if that token was valid, calling the APIs to check to see if it actually had access. And that's evidence of supreme malice. This thing was checking to see if the credentials worked before it took the risk to exfiltrate that data. Now imagine this is happening on your machine. One moment you run npm install like any other day. The next, an invisible parasite is rifling through your environment variables, your config files, plucking out your GitHub access tokens and API keys. But it didn't stop there. It sets up the next stages of its attack right under your nose. After gathering and verifying the credentials, Shai-Hulud moved to persist and exfiltrate. And exfiltrate's a word you're going to hear a lot in security. It's essentially getting data out. Once you break in, you find something of value. Now you need to get it out. It used stolen GitHub credentials to do something rather clever and creepy. It would create a new public repository in the victim's GitHub account called Shai-Hulud and dump all the stolen secrets into a data.json file in that repository. In parallel, it planted GitHub Actions workflows in some of the victim's repositories to ensure that it could continue siphoning data via continuous integration builds. The workflow was designed to trigger on new pushes and would do things like post the contents of the data.json to an attacker's webhook, and even print a base64 encoded secret to the actions log. Essentially, Shai-Hulud set up multiple redundant channels, webhooks, workflow logs, public repository commits to exfiltrate the stolen goodies. Even if one method was blocked, the data might still sit in a public GitHub repository where a hacker could later retrieve it. And it gets worse. Shai-Hulud would then use the access it stole to spread itself further, automatically, with an NPM token for the compromised maintainer. And this is a token you use to publish dependencies to npm.js. The worm logged into all these registries as that user and looked for all the other packages they controlled. For each one, it ran an update package function to infect those packages too. This function would download the package's tarball, unpack it, inject a malicious bundle.js file into the post-install script, bump the version, and republish the package to npm. In other words, Shai-Hulud used the victim's own credentials to Trojanize their other projects. Each newly published version would contain the worm as well. Now, any downstream developer who installed those packages would unwittingly pull in the malware, and the cycle repeats until new victims have more compromised dependencies. And this whole process was silent. It's not like there was an announcement on your laptop if you downloaded a compromised dependency. Most Node or JavaScript developers are running npm update or npm install and just leaning back, maybe going and getting a cup of coffee because it might take a minute or two to install thousands of dependencies. Little did they know that when they were doing that, they were essentially running the program that compromised their own machine. Within days of discovery, the scope was jaw-dropping. What started as a handful of compromised packages ballooned to hundreds of infected packages and over 500 tainted package versions being published. Maintainers who got compromised were unknowingly propagating the worm to their users by publishing new versions laced with malware. The community and registry operators scrambled to respond. CISA even issued guidance to pin dependencies and rotate all developer credentials immediately to everyone. Imagine the chaos, dozens of popular NPM packages suddenly turning malicious. Hundreds of projects now needing emergency credential rotations, CI pipelines halted to purge infected caches. And just so you know, if you're a developer at a startup, you ran that routine npm update on a Friday afternoon, unknown to you, one of your transitive dependencies of thousands might have been affected by this maintainer. It's not like the lights changed to red and music played to let you know that you've been hacked. It wasn't that dramatic. You might not even know. So I encourage all of you to go look at your GitHub repositories, see if there's a random new repository you didn't catch. GitHub and npm.js have been collaborating together to make sure that this is fixed, but I will tell you that there's still some signs that this thing was out there. So you should go look, because someone might have been using your credentials without you even knowing. And this is why it's so disruptive. One analysis summarized it well. Shai-Hulud turned a routine dependency update into a full-scale supply chain attack. And what used to take an attacker weeks or months happened in hours. Researchers have dissected Shai-Hulud's guts. They found a two-stage design. It's a tiny bootstrap script in the npm install hook, just a few bytes of obfuscated JavaScript, and a set of larger modules that handle the heavy lifting once pulled in. The bootstrap's job was just to recon the environment and fetch or unpack the next stage if conditions were right. And this is a cunning way to avoid detection. It decided if the machine wasn't a valuable enough target, it didn't even continue, it just stopped. The heavy modules did all the dirty work. They ran tools like Trufflehog to scan for secrets. They called cloud metadata URLs. They created those GitHub repos and actions. They did the republishing of packages. The code was also heavily obfuscated, lots of base64 blobs, XOR encoding, and dynamic evolves to hide its behavior. It even checked if it was running in a sandbox or an emulator and would try to lay low on personal machines. All of these tricks made Shai-Hulud hard to detect until it was too late. But here's an interesting observation. For all its sophistication, Shai-Hulud was remarkably noisy. It created public GitHub repos named Shai-Hulud. It was pushing visible GitHub actions, workflows. It dumped secrets into public repos. It's almost as if the people who made this worm wanted to be caught. If this took a more subtle approach, perhaps encrypting the data, using less obvious exfiltration channels, this spreading activity might not have been caught. They might have been operating it undetected for much longer. So one has to wonder whether the attackers were overconfident, testing defenses, or had other motivations beyond just stealing credentials. Perhaps the original author was seeking attention rather than information. And I'll leave you with one more thing about Shai-Hulud. Shai-Hulud was the first, but not the last. And the next time someone does this, they might be a little bit more brazen, a little bit more public. There were far more effective and undetectable ways to exfiltrate these credentials than creating a public repository in a compromised account. To sum it up for Shai-Hulud, this was a pioneering worm in the NPM world, and it was a nightmare scenario where trusted open source packages became the attack vector. Its key goal was to grab developer credentials at scale and use them to spread further. If that sounds terrifying, it is. But unfortunately, Shai-Hulud was just the opening act. Right on its heels, we got hit with another campaign, one with a very similar objective but a different approach. This one was codenamed Phantom Raven. Just when the NPM registry users were catching their breath from Shai-Hulud, along came Phantom Raven. This one emerged around August 2025 and came to light in October. Phantom Raven is also a supply chain attack that targeted developers' secrets, but it didn't operate by infecting maintainers one by one. Instead, the attackers themselves flooded the NPM repository with malicious packages, 126 of them to be exact. All of these were designed to steal credentials from any developer unfortunate enough to install them. And what's especially interesting about this one is how they lured the developers into installing these malicious packages. Many of the Phantom Raven packages had names that imitated legitimate projects or sounded plausibly useful. In fact, researchers noted a lot of them were generated by AI hallucinations. This is when an AI system running in Cursor or GitHub Copilot might hallucinate the name of a package. And I can tell you how this happens. If you're a JavaScript programmer and you need to, say, identify unused dependencies. Let's say you want to clean up your package.json file. I've done this before. You go into Cursor and you say, hey, help me out. I need you to go look at my package.json file, identify all the dependencies I don't need, and get rid of them. And again, I'm not picking on a model, but let's say you're using Sonnet, Claude Sonnet 4.5, and you're running in agent mode. So Claude Sonnet in 4.5 in agent mode is going to go and say, okay, first I need to go look for a package that can help me identify unused imports. And it's going to go look in npmjs.org. And when it does this, there's a good chance it might search for unused-imports. And your agent might say, great, I've found unused imports. I'm going to use it to now scan for unused imports. When in reality, the real package that it should have used was something like eslint-unused-imports. Well, guess what? There's a reason that I used unused-imports, because that was one of the packages that was compromised in Phantom Raven. So again, this is an intelligent use of AI This is an attacker using the tools that developers use and understanding that they can easily be tricked in downloading something that is malicious. Phantom Raven's packages often impersonated known tools. For example, some pretended to be related to GitLab or Apache projects, and at first glance, a busy developer might not even realize it's fake. In fact, some of the malicious packages might have done what they were advertising to do in the first place. But by the time of discovery, they had over 86,000 downloads. That's tens of thousands of potential victims, probably more if you take into account the fact that some people cache NPM dependencies locally for others to use inside of a company. So what does Phantom Raven do once it's installed? This attack is a little different from Shai-Hulud. It uses a mechanism of remote dynamic dependencies, RDD. And that sounds a little more advanced than what it actually is. If you look at a JavaScript file or a Node.js file, you have a package.json file, and that's the file where you define your dependencies. And you usually define a dependency with a dependency name and a dependency version. And so, for example, let's say you're creating a React app. You might depend on React version 19.0.1. And NPM is a package manager. It's going to go look at a repository for React 19.0.0.1. And that's easy. But you can also do something else in that package.json file. You can put a URL. And if you use a URL, none of the existing security scanners for NPM are even checking. It's just going to have NPM go download whatever is at that URL and execute it. And if that dependency has a post-install script, guess what? Not only are you hacked, but nothing's going to verify that the contents at that URL have changed. Again, remember, this is a repository manager. When you publish an artifact to a repository manager like npmjs.org, the idea is that when you download something, it's going to be the same no matter how many times you download it. In this case, one of your dependencies points to an external URL, so every time you install it, it's going to some external system and downloading something new. So this is smart, because this also meant that the attackers could change the code over time. And this is like a Trojan horse that calls home for more instructions. This post-install script would talk to this external URL, and once the Phantom Raven payload runs, it immediately profiles the victim's machines. One of the first things it does is search your environment variables to see if something looks like an email address. And this is intelligent because whoever wrote this was trying to figure out who they got. Are you working for a company that they're targeting? Do you have an email domain that matches with something that they're after? It then proceeds to hunt for all sorts of developer credentials. According to Koi Security, who discovered Phantom Raven, this malware systematically collects authentication tokens for NPM, GitHub, GitLab, Jenkins, CircleCI, and GitHub Actions. It's targeting the exact services a developer uses to build and deploy software. And if it grabs your NPM token, it once again, like Shai-Hulud, could publish packages as you. If it grabs your CI tokens, your GitHub personal access token, it could tamper with your code or pipeline. So this is another example of the holy grail for supply chain attacks. And Phantom Raven's operators clearly built this malware to vacuum up as many keys as possible. Phantom Raven also has interesting exfiltration methods. It uses 3 channels to send your data out. It can encode data into an HTTP GET request. It can send JSON data via an HTTP post, or it can open a WebSocket connection to stream data out. Multiple redundant paths, just like Shai-Hulud, and this ensures that information gets back to the attackers. And because it fetches code remotely, it was able to evade detection for quite some time. Just using a URL in package.json was one of the vulnerabilities. Traditional code scanners looking at NPM packages would see nothing amiss, no dependencies, no obvious malicious code, since everything happens dynamically during install. So there were a lot of similarities between Phantom Raven and Shai-Hulud. Shai-Hulud might be a little more complex because it was self-replicating, but Phantom Raven took a different strategy. They just published malicious dependencies themselves. And the scale was significant. Again, 126 packages were identified, and they were downloaded 86,000 times. The security community, Koi Security again, published IOCs and lists of those packages, and you can find them. You click on the links in the show notes. But this is now a cat and mouse game. These are 2 attacks in 2 months that are fairly impressive on NPM. And the key takeaway of these two stories are that attackers are innovating every month, every week, every day to attack the developer layer of the software supply chain. Shai-Hulud and Phantom Raven may differ in method, but they have the same goal, and that's to look at all of the mess that you have on your file system. Now, before we move on, because I want to make sure you don't feel comfortable knowing how these things work, I want to talk about something new, even newer than Shai-Hulud and Phantom Raven. There was a story that broke yesterday, and it was fascinating. Someone identified a worm, something that was self-propagating, but it had a little bit of a different approach. It was starting to use AI itself to modify itself. And why is this a big deal? It's a big deal because one of the ways that security departments detect some of these vulnerabilities is with things like Yara. Yara looks for a signature of a known vulnerability. Well, if we have vulnerabilities that are now becoming intelligent enough to alter themselves, even slightly, that makes it much more difficult to identify the signatures of the files. But it also brings up another possibility. If you've been using tools like MCP servers and Cursor, you've been amazed. There are things you can get done now in a couple of minutes that might have taken you a week, 3 years ago. One of the things I reported about Phantom Raven in this piece was that one of the first things it did is it looked at your email address to try to figure out who you are. Think about a vulnerability that can not only modify itself, but it can start to use things like MCP servers. Now, again, if you're tracking this information on network, you're going to be able to track something that's very chatty. But the other thing to realize is a lot of these worms have very innovative ways to communicate with one another. There was a tool, I believe it was called Sesame Op, that Microsoft talked about yesterday. And one of the things it did is it was leveraging OpenAI's Assistant API to be able to exchange information with different nodes in the attack. In some ways, it was using OpenAI's Assistant API in the same way that a lot of these attacks have been using Internet Relay Chat in the past. But if these things are getting smarter, I would suggest that today is the day that as a developer, you need to make sure that your credentials are in a safer place. Because I think that this acceleration of worms and dependencies and supply chain risk, it's accelerating exponentially. So in the next section, I'm going to talk about the things that you can do to help protect yourself. Okay, in this third segment, I'm going to talk about next steps. What can you do to secure your developer workstation? And what habits do you need to change to adapt? Before I get started, I just want to say something that's maybe the worst operational security I could possibly have, which is I am guilty of many of the things I'm about to tell you to stop doing. And I have decided that today is the day that this all stops. The thing that should disturb you the most about Shai-Hulud and Phantom Raven is how silent they are. Shai-Hulud was particularly noisy, yes, but there's a good chance that you know someone who's affected, and they didn't even know. Now, luckily, I think GitHub and NPM.js took some steps to address these things behind the scenes, but this affected more people than even know that they were affected. So what can you do now, today? The first thing I'm going to suggest is purge secrets from local files and repositories. If you can open your terminal right now and run cat.env or .env local and see a file that has passwords in it, that needs to change. Because if you can do that in terminal, then something else can as well. Instead, you need to move your secrets, or your passwords, your keys, to secure vaults. Things like 1Password, LastPass, HashiCorp Vault, AWS Secrets Manager, GCP Secrets. Whatever you do, don't store these things on your file system. And you can provide these to your apps on demand rather than hard coding them. With 1Password, you can eliminate .m files entirely. They offer a command line interface and an SDK integration that allows you to inject secrets at runtime. For instance, with 1Password's command line interface, it has an op run or a secret reference injection feature that will load an environment variable from the vault when your app starts, without ever having to write it to a disk. And that means even if malware searches your file system, it won't find the secret in plain text because it was never there. It only lives in memory when needed. If you must have local config files, at least keep them out of source control. Git ignore them. Consider using OS level encryption. Encrypt the folder or disk. But Vault integration is becoming easy enough that it's worth doing, and it's worth doing today. I would encourage you to prepare for next week's vulnerability because the rate at which these things are being released is increasing. Credentials should never just be sitting unencrypted on your drive, and if you have API keys in a text file called keys.txt, get rid of that. Let's fix this problem. It's the easiest thing for us to do today. The next thing we need to have is stronger authentication and more discipline over the keys. A lot of these attacks succeeded because they exploited unattended, long-lived access tokens or credentials, and I'm guilty of this as well. Every time you create a token for npm.js or for GitHub, you're often allowed to choose an expiration date. Go with 30 days, go with 60 days. But whatever you do, don't just choose an expiration date 10 years in the future. And you also need to reduce the scope of any token you create. When you create a GitHub personal access token or another GitHub token, you can choose what it's allowed to do. And don't just give it everything. Developers often have tokens on their laptops that live forever and that have root access, admin access to everything. Don't do that. The other thing you need to do is enable two-factor authentication, even if it creates friction. You can use two-factor authentication for just about everything, but the other secret to share is that not a lot of people do. Use passkeys whenever you can, use two-factor authentication, even for things like publishing NPM dependencies. I know you might want to automate everything, but giving up a little bit of convenience is a price you might have to pay to be more secure. And then here's an obvious one, and I can't emphasize this one enough. If you're a developer and your laptop is full of secrets and credentials, please lock your workstation when you leave your desk. It's so easy. On a Mac, you can set up a key combination and just turn it into something that you do. Every time you stand up, you automatically lock your computer. Don't give it the minute or two or the 5 minutes it might take to decide that it has to shut down. I remember when I was in college, we used to prank each other. So we'd had up a computer lab, and if someone got up to go use the restroom and they left their workstation unlocked, they would return to see something completely inappropriate on their screen, or some weird script would be installed that would print out nonsense characters every 10 minutes. We would like to mess with each other to make the point. You should lock your workstation. I'm not trying to make you paranoid, but insider threats for security are an actual thing. There were some stories yesterday about insiders exfiltrating data at an AI company. You need to get up to do something and leave your laptop on your desk. Make sure no one can log into it. Make sure no one has access to it. The easiest way to compromise your laptop is just to sit down in front of it. The other thing to do on security for developers is, please make sure that when you set up your operating system, that you're encrypting your disk. File Vault on macOS, BitLocker on Windows. If your laptop is stolen, what you want to know is at least the data is secure. And use a strong account password. It might seem unrelated to worms, but if malware does get in, having a strong OS password and not running as an administrator all the time can limit what it has access to. The third thing I want you to think about is keeping your development stack updated. Update your dependencies as well. We saw how that unpatched Plex app led to a huge breach at LastPass. And we also saw recently that a React Native development tool called Metro has a vulnerability that's wide open to anyone on the network. Again, I want to emphasize that React Native problem requires an update that you should be doing today. It scored 9.8 out of 10 in terms of severity. I guarantee you, if you go look at your developers, if you work somewhere that has developers, go look at their IDEs, go look at their versions of Java, versions of NPM, their package managers, the runtimes, you'll be surprised. Some of them might have had several birthdays. It's important to make sure that your tooling is up to date with security patches. Turn on auto updates where feasible, and yes, it can be annoying to interrupt your flow for an update, but it's far less annoying than finding out that a known bug allowed a ransomware into your laptop. And I also want to say it's ironic. One of the issues with Shai-Hulud and Phantom Raven is that they're starting to infect dependencies. The same also applies to your third-party libraries. All the code you bring in, dependencies should be regularly scanned, use npm audit, npm outdated, and update, but be a little bit more careful in the presence of some of these worms. A startling statistic from a few years back is 79% of third-party libraries and applications are never updated by developers after being added, ever. Don't contribute to that figure. If you have a dependency with a known vulnerability, patch it. Use automated tools like Dependabot or Snyk. Attackers like Phantom Raven capitalize on the fact that developers may not scrutinize what they install, especially new packages. It's entirely impractical for you to pay close attention to your dependencies and thousands of transitive dependencies. But you do need to start paying attention to the news. Phantom Raven, Shai-Hulud. Your goal should be that the next code name that comes out for the next attack, that you know it. Because if you keep track of Phantom Raven, you'll also be able to see a list of the dependencies that it affected. Now, I mentioned this before, GitHub, npm.js, they're doing their job to make sure that the compromised dependencies are gone. But you also cannot depend on that. You need to start looking at your dependencies. Double check that the packages that you depend on, just your first level, that they're real. Try to see if they have users. One of the things I've noticed is with Cursor and asking it to do something, it'll start adding dependencies. And in the case of that unused imports, that's how Phantom Raven got in. But I have also noticed there's been more dependencies published. Again, GitHub has reported that there are 420 million repositories, and that's of 2023. A lot of people have started to publish open source libraries with generative AI, and a lot of them don't have any users. And that's one of the warning signs. You need to understand your dependencies, not just what they do, but who created them, because dependencies are now a new avenue of attack. The fourth recommendation is secure your continuous integration deployments and your repositories. These worms target not just the individual machines, but sometimes they really like to compromise a continuous integration pipeline or a machine, a Git workflow. Developers need to extend security to those environments. Use the principle of least privilege for continuous integration. An example, if your continuous integration build only needs a token to pull packages, don't also give it admin rights to publish packages. Segment credentials, separate tokens for separate purposes, so that one stolen token doesn't grant the attacker access to your entire business. Also, implement branch protections. Consider requiring code reviews, especially for sensitive files like GitHub Action workflows. Shai-Hulud tried to add malicious workflow files, and a well-configured repository might have caught an unapproved workflow addition. Some orgs even enforce that adding and updating a GitHub action requires a pull request and cannot be done from an automated script without review. These kinds of guardrails can disrupt an automated attack. Now, the other thing about securing your repository managers or your CI builds is set up email alerts. Every time I publish something to npmjs.org, I get an email. And so if I get an email for something and I didn't do it, I'm going to know right away something wrong has happened. It might be annoying, but turn all those emails on. If there's a GitHub action that should only run once a week, make sure it sends you an email after it runs. The fifth recommendation is educate and embrace a security mindset. Finally, and most importantly, change your culture. If you personally have been lax about security, it's time to flip that switch on. Remember that survey. Most developers didn't see security as a top priority. That needs to change. It's as important as not shipping code with obvious bugs. Start treating your credentials and your access token as seriously as you would treat your production database, because effectively they are production assets. If you use tools like GitHub, they have secret scanning on every single commit and push, and that's really useful. Consider using those tools. There are open source ones like GitLeaks, TruffleHog, and of course GitGuardian for enterprises. It's better to catch your own error than to wait for an attacker to find it on GitHub. Also, allocate time for security fixes. If you're the lead or a manager, push for patch time and sprints. It was noted that developers don't update libraries often due to lack of time or fear of breaking things. Address that by scheduling maintenance windows. Write tests to gain confidence in updates. And foster support from leadership to prioritize those updates, in addition to new features. Leadership needs to give developers the breathing room to do security tasks, or it's going to have to suffer through embarrassing lapses. One more fun but effective practice, simulate phishing or social engineering tests internally. Remember, Shai-Hulud's entry was likely a phishing email to an NPM maintainer. Stay on your toes for suspicious emails or login prompts. Treat unexpected security alerts or password reset emails with caution. Verify their legitimacy. Many companies do periodic fake phishing emails to train staff. Developers should be no exception. We hold critical access, and we're prime targets for spear phishing. So don't be the one who clicks on that bait. So to close this out, the most amazing target for bad guys right now, it's you. because that's who has all the credentials, all the access, all the code. These recent Shai-Hulud and Phantom Raven worms prove that attackers are investing time and creativity to infiltrate your laptop. It should be a wake-up call. And if you're listening to this and realize you've been a bit casual about security, don't feel bad, you're far from alone. But use this moment to change course. Secure your workstation like it's production infrastructure, because in a way, it is.